Now we'll discuss for the third harmonic, and third harmonic is also known as the second overtone. Now the waves generated in the open pipe will get a shape like two loops in the middle, and antinode is formed at the open end. It will be the pattern of stationary waves generated in the open pipe for the third harmonic. In this diagram we can easily observe here, these are the antinode positions where the amplitude is maximum, and these are the node positions where the amplitude is equals to 0. Now for the third harmonic, the complete length of the tube is now converted in how many wavelengths? So it is a one loop and it is a one loop. So these are the two loops, and because it is a half loop on the right hand side and half loop on the left hand side, so it becomes one loop. So in addition we have the three loops here. Basically three loops means the 3 lambda over 2, that means 1.5 wavelength. Now the complete length of the tube is equals to the 3 lambda over 2, because we know that the two loops will form the one wavelength and the one loop will form half of the wavelength. So 1 plus half is equals to 1.5 wavelength or 3 lambda over 2. So lambda is equals to 2 times of length divided by 3. To calculate the frequency, we will use here the wave equation, that is V is equals to F lambda. The F is equals to V over lambda. Now we will substitute the value of the lambda in this equation. So it becomes the V over 2L upon 3, and now this frequency can also be written as 3V over 2L. And because we are talking about the second overtone, we can use here the 2 in the subscript of F. So it becomes F2, that is equals to the 3V over 2L. And now we want to show this frequency of the second overtone or the third harmonic in terms of the fundamental frequency. So we will write this F2 like 3V over 2L. So it becomes the F2 is equals to the 3 times of F1. That means 3 times of fundamental frequency, not F1, F0. F2 is equals to 3 times of F0. It means the frequency of the third harmonic or for the second overtone is equals to 3 times of the frequency, fundamental frequency. Now we'll discuss about the fourth harmonic or the third overtone for fourth harmonic or the third overtone so F1 is equals to 2 times of F0 and F2 is equals to 3 times of F0. It means we can write here the F3, that is for fourth harmonic and third overtone, is equals to the 4 times of F naught. Similarly, for general term, we can use here the Fn, and here we can use the n plus 1 F naught, because if you observe this term, the F1 is equal to 2 times of F naught. Here we have the 1 and here we have the 1 plus 1. That means the value here, we have the one addition of the value of the subscript of F, and here we have the 2, that is the addition of 1, that means 3. So we can generate here the general term just like Fn is equals to n plus 1 into F naught, where n represents the number of overtones and F naught is equals to the fundamental frequency, and the value of the fundamental frequency is equals to V over 2L. And now, students, this general term is not important for the examination point of view. Only the sequence by which we can find out the frequency or the calculation of the frequency for the different harmonics and overtones, it is important. Okay, students, thank you so much. Now the topic is completed.